what Teilhard would say about this is that the cup itself doesn't possess consciousness. And all this will become clearer, I hope, as we go along. All of the later stages of Teilhard's argument clarify the earlier ones. But this cup is not much more in its aggregate, does not possess much more within this than the individual atoms that make it up. Let's say this is made of aluminum. It's made of aluminum atoms. There's no complex organization. It's just an aggregation. And so the level of inwardness in this cup is more or less the inwardness of the individual aluminum atoms that make it up. If it had some kind of complex organization, then its inwardness would increase.
As in the case of a human.
As in the case of a human or anything that has been through the process of evolution. This has not been through the process of evolution in any way. It's been aggregated, not evolved. In order for something to have more within this than pure elemental matter, it must lie somewhere along the curve of evolution.
But in the primordial material, the same material that was in a human was in a cup in some shape or form. So how do you distinguish hierarchies?
Again, in terms of complexity. And at this point, it's crucial to realize that Teilhard is using the law of complexity and consciousness as a heuristic device. He's saying, let's work with this and see what happens. He's not assuming it, and he certainly hasn't proven it. The proof for it will only come much, much later in the argument, at the very end of the first half of the book that you read for this week. In a way that you might not have noticed when it happened, he proves the law of complexity of consciousness. At the moment, it's just a hypothesis that this is the case. We'll see later on today how that gets proven. Okay. The next, yep.
This is kind of a related question. This just came up for me, but as you're drinking that soda now, even though it's unconscious, it's becoming part of you, and the way through your system and eventually becoming your thoughts. So how did we deal with that transformation?
He deals with it in this wonderful way. He talks about two kinds of energy that exist. You may remember radial and tangential. Tangential energy is normal energy as it's known to physicists, the energy that interacts among material objects. Radial energy is the energy of the within. And the more radial energy, according to the law of complexity and consciousness, the more radial energy there is in an object or an organized entelechy of some sort, the more complex it will be. And radial energy, therefore, is that energy which is driving toward complexity. Tangential energy is normal physical energy. And Teilhard says we have to realize that there is a connection between these two energies. You can't have one without the other. And the example that he gives is You can't think without eating. Your inwardness, your consciousness would go out of existence if you didn't absorb into your body material substance that is out. If you didn't take in, if there wasn't this outward process, this process of outwardness as opposed to withinness going on, eating of bread, then your consciousness and everything associated with it, such as thought, could not occur. So he says these are inseparable. You can't have radial energy without tangential energy. You can't have a within without the external processes. But he says, let's take a piece of bread. You ate a piece of bread this morning, and let's say Einstein ate a piece of bread this morning. That same piece of bread, the same external energy, in you goes in one direction, in the dimension of the within. In Einstein, it goes toward his proving the theory of relativity and producing in the domain of the within a radial force sufficient to blow up the entire planet. The same piece of bread. So, although these are connected, there's no one-to-one correspondence. There's no way to say how a piece of the outer world that you take into yourself will be transformed in the domain of the within.
On the theme of radial energy described by complexity, that's part A. So that's part B, and that is that it also drives central unit.
Yeah. But I think we won't get to that till next week. What does he mean by driving toward complexity? Well, it's very simple. If we begin with subatomic particles at the origins of the universe just after the Big Bang, then the subatomic particles coalesce into something more complex, an atom. How do we know that atoms are more complex? Because they contain subatomic particles within them. They must be more complex. Not only do they contain them, but they contain them in a particular arrangement, in an organized way. And so the atoms must be of a higher order of complexity than the subatomic particles. But notice that there must have been intervening stages, various interactions of subatomic particles that didn't cohere in the early stages of the universe. All kinds of arrangements. And then, under the right energies and the right circumstances, a pattern emerged that was harmonious and that clicked, and you had atoms. The important point here is that these are granules. Like the subatomic particles, we have the appearance at a higher level of granulation, new granules. Then things go further, and eventually atoms begin to combine into molecules. And there's an intervening stage. Molecules are another granule, more complex than atoms. They are made of atoms in an arrangement or complicated order. But what's the intervening granule between an atom and a molecule? Do you remember?
Polymer?
What?
Not a polymer, no.
Polymers are more complex molecules.
Oh yeah, that's right.
Peduncle.
What?
Peduncle.
A peduncle? No, that's much further down the line. Stars. Stars.
Oh, developmentally, I see.
Developmentally.
Not structurally.
This
but
is
developmentally. yeah.
chronological.
Yeah. Okay.
This is the evolution of the cosmos. The important thing here is that stars appear before molecules do. In stars, you get more complex elements cooked up. And it's only when you have a more complex array of atomic particles that they can begin to combine to form molecules. But stars are granulated objects. They are objects that have their own autonomy, integrity, and stature.
David, what do you mean when you use the word autonomy? Because it's not the same thing that we use in other contexts. Right.
I'm not exactly sure. I'm trying to point to the, I guess integrity is a better word than autonomy.
So autonomy means self-determining, self-shaping, making what's norms and all.
Yeah. And in fact, they are doing that because the hallmark of an intensified within-ness is an intensified power of spontaneity. Atoms are more spontaneous than subatomic particles are. They are more in the direction of complexity. And so, well, we all know where this is headed. Molecules lead to the polymers, which are more complex molecules. They're prebiotic. Although we need another granule here. It's on planets that molecules become more complex. Prebiotic. Polymers are very complex molecules that are what life eventually gets made out of. And then you have life. So, and then of course it goes further with the whole evolution of life up to us. What Teilhard is going to be saying, this is still an answer to Rick's question, is that atoms are further along this dimension of complexity than subatomic particles are, and therefore atoms are more alive than subatomic particles are. Literally. They have more of that which later turns into life. Even further, since evolution, as Teilhard is going to be pointing out at the end of this section and into next week, the process of evolution seems to have ended up in human beings. Atoms are more human than subatomic particles are, literally. It's not a metaphor, it's not an analogy, it's a fact that atoms are more human than subatomic particles. That's the kind of deep shift in structure of thinking that Teilhard wants to move you to. So you have to get to the point where you can grok that. You can grok that an atom is more human than a subatomic particle.
So we haven't got to the within-ness yet until we get to life.
No, within-ness is there from the very beginning.
Okay. So somebody like Steiner, who says, and other philosophers who said planets have their own kind of consciousness. they're kind of an entity with their own group consciousness, so that would fit into this.
Absolutely. Yep, absolutely.
Oh, sorry, Gwen had her hand up. And then, okay.
I'm struck by the shift of scale.
Can't hear Gwen.
I'm sorry, I was struck by the shift of scale.
From atoms to
From
stars.
atoms to stars, and then molecules to planets, and then you start working on the meso after that. And I'm wondering, I'm just on a purely physics level, whether it's because, I know the forces, the sort of strong weakened electromagnetic forces are operating on this micro scale, and then is there enough mass that then gravity can start operating and on a large scale, and then that creates some conditions for still more transformations on a micro scale, which creates
Exactly. It's a
conditions
kind
for
of
more
oscillation.
transformations on. That's fascinating.
That's how Teilhard sees it moving. But the thing that holds it all together is the even deeper phenomenon of granulation. That's this primal thing that although the oscillation goes back and forth between the tiniest and the largest, it's still a process of leaping from one form of granulation to the next. So that's why, I don't want to jump ahead then and go already,
So,
but you'll see how the last step is another one of these oscillations.
actually, Linda, but then
Yeah, mine kind of goes on from Wednesday, that our very life here depended on what stars did and then what planets did. My whole history. Isn't that just marvelous, just to put all of that things?
It's amazing.
How interconnected we really are.
It's,
If you don't believe in astrology, you kind of need another reason to look at that.
and the thing is that all this is obvious. I mean, it's self-evident. And yet science refuses to accept the mainstream scientific view, absolutely refuses to accept that there is a process of increasing complexity taking place in the universe.
Is that what they refuse to accept, or that there's inwardness from the beginning?
that
Well, both.
most
But that one
of the,
seems to be the critical one. I mean, why is, I'm not thinking which scientists object to increased complexity? I don't,
or Gould, Stephen Jay Gould, for
is a
instance.
prime example.
increase complexity.
There's,
Yeah,
he-
there's nothing happening in the universe. It's just a random concatenation of meaningless phenomena, and there is no complexification happening. You could equally well decomplexify.
But that's, but are they denying, let's take Gould, is Gould denying complexity, or is he denying the built-in pattern or principle of complexity?
He's denying both. Certainly the latter, but
Got that.
even the former, because the former is dangerously close to requiring the latter. In other words, if you admit that there is a regular increasing complexity in the universe over time, then you are forced to admit that that is somehow a law of nature, that's meaningful, that there's a telos, that something's happening, and it's going somewhere. And the mainstream scientific mind is absolutely opposed to that. But we won't be able to understand why the mainstream scientific mind is opposed to that until we read Erich Neumann's book, The Origins and History of Consciousness. Then that, I think, will become clear.
just two things that occurred to me. Well, with regard to autonomy, an important concept in the sciences of complexity is self-organization, where we see where autonomy is really correlated to the degree of the complexity of self-organization. And I'm not sure what scientists, physicists would say, but whether atoms are self-organizing. It seems like they just come into being, and they are. They don't seem to be self-organizing in the same way that stars are. Stars are like giant cosmic eddies, and they are self-organizing. So they're self-organizing beings. So it seems that stars are the first self-organizing beings. And then molecules aren't self-organizing beings. It's not until you get the organic molecules, which is basically life, where you get molecular self-organization. But planets are self-organizing beings, right? So you go from stars to planets, and then from planets to life. In each case, you're dealing with a higher, more complex order of self-organization and autonomy. And the intervening steps, I just noticed this, are not self-organizing. So what that means, I don't know.
I'm not sure about that. I don't know how you would define self-organizing to exclude
Atoms?
atoms forming out of the resonance patterns of subatomic particles through trial and error.
Yeah, I'm not sure. I'm not sure how either. It's more of an intuition at this point, except for the fact that it seems that atoms come into being more or less instantaneously, and they are the way they are for all time,
That's the point.
right?
That's the whole point.
Right.
Every one of these moments of granulation for Teilhard seems to occur instantly.
Right.
And that's because of this process that he calls the suppression of the peduncles. I don't know if you remember that.
Suppression of
The
the peduncles.
suppression of the peduncles, which means that it is always impossible to view the beginnings of something. He gives the example of the discovery of the chariot. If we as archaeologists look back in time, the chances that the first chariot ever built survived in some way and that we will discover it is almost zero. Zero, basically. We will not discover the first chariot. When we first see chariots looking back through time, the first chariots we see are everywhere. We'll never find the first one. And this is what he means by the suppression of the peduncles. Atoms appear to be everywhere suddenly,
Right.
but they went through an evolution out of various experiments that subatomic particles conducted, bouncing against each other until the right experiment produced the possibility of a higher level of organization. And that's what happens at every level. And this is absolutely crucial. Let's say subatomic particles are bouncing against each other in every conceivable way. Let's say that these are various ways in which subatomic particles bounce against each other. At one point, the subatomic particles happen to bounce against each other in a way that coheres. And a new level of complexity emerges at that point, and that's the realm of the atoms. And then the atoms do the same thing. They bounce against each other in various ways, experimenting, and the technical term that Teilhard uses here is groping. That's the process of cosmic evolution, a front of experimentation that moves along, groping, trying everything until it finds a place where an opening occurs into a greater level of complexity. And so atoms do that until they find the place where molecules...
But David, there still seems to be a qualitative difference and a phenomenological difference between a star, which is constantly in the process of spending itself and radiating out. Maybe it's different for radioactive atoms, where they're maybe like many stars, except quantized many stars, I don't know. But all of the other atoms, as far as I know, don't radiate in the same way, aren't involved with this kind of ecological exchange with their environment in the way that stars are, in the way that planets are. And that's why stars die and planets die. Atoms don't die unless they're radioactive. I mean, they might die, but when they die, the cosmos, the physical cosmos dies, right? Like once they're minted, they sort of last forever.
I'm not a physicist, so I don't know, but I think even atoms are subject to the third law of thermodynamics, that they are heading toward absolute breakdown. They're not permanent. They have a lifespan.
As far as I know, I don't think that's the case, except
Any
for
physicists
radioactive atoms.
Is it the key thing there, though, that it's chronological? That's how the universe birth is also.
That's the key thing, but what I'm pointing to is just another harmony, an interesting harmony of relative to this question of autonomy and self-organization, particularly since it's at those points where a new or a jump in the order of complexity occurs. There was another point, but maybe you want to have a break first. I don't know.
Yeah, take maybe one more question. Who was first? Sean?
I'm just wondering what the relationship between the concepts of emergence and punctuated equilibrium are to the use of groping and the suppression of the
I think that groping and suppression of peduncles are Teilhard's rudimentary, intuitive attempts to take a first stab at what later become more well-developed concepts.
The punctuated equilibrium would be completely coming from the other viewpoint, the Gould's viewpoint, where there isn't any inward groping.
Right, except that it does recognize the existence of phase changes.
Right.
And that will be a crucial point for Teilhard in the next section. So let's take a break. Try to keep it short because there's still a lot to do. And
one link with Aurobindo, and also a terminological question. I don't have the French text with me, so I'm not sure whether granulation is granulation. I'm assuming it's granulation. If that's the case, and I'm assuming that the root of granulation is granus, granus, seed. So not only would there be the idea of atomicity or particularity, but that in each granule from the beginning is a seed.
absolutely.
Within which is enfolded the potential of everything else. Okay. And excuse me, on page 71, he says, in the world, nothing could ever burst forth as final across the different thresholds successively traversed by evolution, however critical they be, which has not already existed in an obscure and primordial way. And this is what you were bringing out, which seems to be a good way of looking at involution, or at least the sign of what Aurobindo is talking about as a previous involutionary process, which we don't. Teilhard doesn't have a concept of involution, but he
starts here. Involution is all pre-cosmic.
Right, but I think as far as I understand his metaphysics, he doesn't have an involutionary process. He has creation, whatever that means. But the creation, as soon as you have the first granules out of the creatable nothingness, he calls it, you have seeds of infinite of potential, at least. So it's a more Thomistic, Aristotelian view of creative potential, which is the other side of the involutionary idea.
Yeah, it's a germ of involution.
The germ of involution.
The germ of the idea of involution
Yeah.
is contained in Teilhard's view of these as germs. Each level is a seed.
And I wanted to ask a question. And maybe this is the problem. He doesn't have this evolution in the beginning. See, I think my problem is, or maybe I'm missing something, you could straighten me out, but this whole evolution of complexity, for instance, we're asked to believe by the scientific mindset represented by Gould that out of this randomness, this chance, we get consciousness. But right at the very first, I thought groping was a very interesting term because it seems like he's groping for an explanation. We're asked to believe that out of this randomness at the beginning is created what is going to end up as the exact antithesis of the scientific worldview. That doesn't seem to me to be consistent. I don't see how, if you're going to make a case for a point of view that is supposed to overthrow the dominant point of view, why start out with random? I mean, in other words, it just pushes the question backwards one step.
Yeah.
And the question is, how does randomness create a possibility? If the possibility wasn't there to begin with, now if he has evolution, as Sean said, then the possibility has already occurred before that.
Yeah, Teilhard doesn't know. The possibility is there for Teilhard, and it is radial energy. Or withinness exists from the beginning. But remember, involution, this whole story of involution that Aurobindo assumes, takes us beyond anything that we can either prove or disprove. It can't be validated or invalidated. It's an appeal to a supersensible private revelation that Aurobindo had that we have no access to. Teilhard is beginning where we can begin, with things that we can all have access to. And that's why he's saying it's a work of science rather than a work of theology.
Okay, so then we are to understand this beginning in randomness then.
It's a beginning, yeah, it's a beginning in randomness, but the beginning doesn't matter. Because for Teilhard, the only thing that matters is the end. It's not that the universe is being pushed forward from the beginning by some well-organized consciousness or process. It's being pulled, not pushed from the beginning, but pulled by the end toward what next week in the second half of the book he will eventually call the omega point, which is the point of final, absolute, infinite complexity. And he's going to talk about what that omega point might be and the intervening stages between us and it. Okay. Now,
David,
yes.
sorry, I'm still Teilhard 101 here. You don't need to do any more with this, but it'd be helpful to know whether, in your view, in terms of what you've said so far, in relation to Sean's question, whether every phase has the potential to self-organize.
Whether every phase has the potential to self-organize. Every phase represents a quantum leap toward a more intense withinness.
I understand, but that's what happened. Did it happen because it had the interiority of each phase has the capacity, had, and therefore it happened
Yes,
to go from one phase to the next?
yes.
Okay. Doesn't that sound more than a germ of involution?
It not only has the potential, it has the drive.
Okay.
That radial energy is that drive toward greater and greater complexity. It's built in.
But then, okay, okay, I mean, you don't need to stop, you can keep going, but what I'm listening for, I should warn you, what I'm listening for is why you're putting all this emphasis on omega, when it seems to me there's an alpha, which Aurobindo calls involution, and Teilhard, in other writings, regards as creation, but really has some interiority which is struggling from the very first atomic, post-Big Bang subatomic particle.
It's there at the beginning.
Then,
It's a law of nature that there is this factor that he calls radial energy that is driving toward complexity. But that's all you need. Just that one addition. You don't need to explain where it came from any more than you need to explain where tangential energy came from.
In your view, this is still scientific. This is not metaphysics.
It's still scientific because it is based on something that we all have immediate access to, namely the direct experience of our own withinness. We know that withinness exists.
Okay, and you're saying that because we have within this, that we experience withinness of our own consciousness, therefore we can attribute it to subatomic particles even though we can't observe it.
Yes.
This is a leap.
It is a leap, but it's the same leap that, well, it's a leap.
Is it a scientific leap?
It may not be fully scientific because we can, once we know, for example, that toward the speed of light, the mass of an object increases, we can go back and even at our scale, we can now measure it. But we can't measure the withinness of anything other than ourselves.
There is another sense in which it's scientific, though. Given the isomorphism of matter and the fact that science believes that the laws of physics are universal, right? So wherever you have matter, they will obey the same laws. Now, the fact that matter with us is organized in such a way that there is a within, and that we are the product of an evolutionary process, given conservation of energy, conservation of mass, and the isomorphism of matter, that withinness must be present potentially, because science doesn't believe in precisely a creation out of nothing. Right? So either science has to say there was a creation of withinness out of nothing, which is completely unscientific, or it has to say that in some sense it was there from the beginning.
Yeah, that's the kind of insight that Teilhard is relying on.
And that's how David started.
Yeah.
I think that's why you could defend this as scientific, is because you started out with the principle of homogeneity as being the basic principle, which if you take that seriously, then whatever we are, we're not just an atomized product of evolution. We are the universe, and therefore everything in the universe at every stage is us in some implicit, if not explicit form.
Yeah.
I can see like how animals and plants as things are evolving and forward and getting ever more complex. What about things like water or light or wind? They don't, I mean, at least from my standpoint, they don't appear to really change or evolve or add.
They don't. They are products of evolution up to a certain point. They are things that appear as part of the existence of the earth. Where did we put planet here? And so there within this is roughly at the same level as that of the planet. But the atmosphere, for example, the wind, is made of elements. It's not even made of molecules. Mostly it's elements, oxygen, nitrogen, it's atomic particles. Well, they are molecules, I suppose. Ozone is O2 or O3 or something. But yeah, they're not much more advanced than molecules are.
But how can some evolve and some not?
Well, let me answer a lot of these questions in advance by saying once again that a lot of this won't make sense until you see where it's headed. The later stages of the argument clarify the earlier stages. Everything works backwards, and that's actually exactly in harmony with the core of Teilhard's vision, namely that everything is being pulled toward an end rather than pushed from the beginning. So you can't really understand it fully until you see later stages and the end.
When we look at separate aspects matter, whether it's water or air, it looks like something that's not evolved.
It looks like it's not
It
evolved.
looks like it's not evolved. However, Helen's position is that when these things come together in a complexity, then it is evolved, because that's what we're made out of. I mean, you take the air and the water through the minerals and put it together, it creates a mystery to it, and that creates consciousness. So these things do evolve. It's just a matter of, if we look at them separately, they don't seem like they have the potentiality of evolving, but they have the potentiality of evolving, and they do evolve. Those things do combine to create consciousness, aren't they?
Well, yes and no.
When you have a newborn baby, where does that come from? It's, what is taken within the woman's body, and
No, that's not where it comes from. Where it comes from is the result of 15 billion years of evolution. You can't.
there's two places. There's the physical thing of the, 15 billion years of evolution. But there's also, you're talking about maybe keeping it scientific. There is that this woman is alive today, and there's a seed that germinates, and then she takes in the water and the air and this and that, and they become part of.
They become part of something that's evolved, but they themselves are not evolving. They are, that's the whole point. They are at this level. The woman is
It's like the
way
bread.
down here.
It's like the bread.
It's like the tangential and the radial, the bread turning in. You need air to breathe, but what happens in the domain of the within as a result of breathing of the air is entirely different from evolved organism to evolved organism. But let me go further, because
When I take in, does it turn into a thought?
I'm sorry.
Are you saying when I take in from the breath, does it turn into thought?
It does turn into a thought, but it has no the particular thought has no relationship whatsoever.
It turns into a thought, and that thought can turn into a consciousness concept. That can be reflective of how I think.
Yeah.
And that,
Well, again, all this will make a lot more sense when we get further and can look back. So let me try to do that. I left this space blank because I wanted to fill it in a way that casts light back again. Before the origins of life, Teilhard says, the earth was covered with an ocean of complex molecules, what he calls the polymers, which are very, very large, complex molecules. And the simple molecules turned into complex molecules for a particular reason, namely that the earth is a sphere and therefore has a finite surface area. And so the simple molecules that spread out around the earth eventually began banging into each other. If the earth were not a finite surface area, the molecules could have just spread out and never had to interact with each other. But because the earth is a sphere, the molecules were thrown back upon each other. And here Teilhard uses the word involution in an entirely different sense from the way Aurobindo uses it. But he speaks about the, on page 72, he says, because the earth is individualized, is a sphere, is contained, matter no longer spreads itself out beneath our eyes in diffuse and undefinable layers. It coils up round itself in a closed volume. How will its inner layer react to such involution? And then again on page 73 at the bottom. Thus, wherever we look on Earth, the growth of the within only takes place thanks to a double related involution, the coiling up of the molecule upon itself and the coiling up of the planet upon itself. On page 74, by the very mechanism of the birth of the Earth, the thin film that covers its surface, in which the within of the Earth was concentrated and deepened, emerges under our eyes in the form of an organic whole in which no element can any longer be separated from those surrounding it. Another indivisible, another granule, that is, has appeared at the heart of the great indivisible which is the universe. In truth, a pre-biosphere. The pre-biosphere is this Earth covered now with molecules that have been thrown back on each other and as a result have become more complex to form very complex polymeric substances. And those polymers then are thrown back on each other until something extraordinary happens. And that is, and this, it's not crude, but it's astonishing. And that is that the next step is unmistakably, inescapably, a process of granulation.